Prasad from Civil Engineering Department, Assistant Professor at Mlritm College. Today my topic is Advanced Structural Steel Design. The course objectives of the Advanced Steel Structures. These are the four objectives. First one is to analyze the bolted and welded eccentric connections. Second one is sketch the influence, align, diagram and truss members. Third one is to estimate the various types of loads such as dead load and live load and roof trusses. Now coming to the last and final course objective is to determine the shape factor and define the theorems of the plastic analysis. Next, coming to the course outcomes of the Advanced Structural Steel Design is these are the four course outcomes. First one is design the eccentric movement connections. Second one is design the truss members subject to the tension compressions. Next, coming to the third course outcome is determine the collapse loads and continuous beams and portable frames. Now coming to the last course outcome is estimate the various types of loads such as dead load, live load, wind load. Now coming to these are the 5 units. First unit is simple connections, bolted, pinned and welded connections. First concept is bolted connections, dead load, live load, transfer mechanism, failure of bolt joints, specifications of joints, bearings, types of connections, tensile strength of the plate and combined shear and tension in the steel structures. Next, slip critical connections of the steel structures, praying action in steel structures. Next, combined shear and tension, slip critical connections in the steel structures. Next, design of groove welds, design of fillet welds in steel structures, design of intermittent fillet welds, failure of welds. Next, coming to the second unit, plastic analysis. Introduction, plastic theory. Next, plastic neutral axis of plastic movement, elastic and plastic section module shape factor. Next, coming to the fundamentals and conditions in plastic analysis of the steel structures. Next, coming to the collapse load and simply supported and propped cantilever and continuous beams in the steel structures. Fixed beams in the steel structures. Next, coming to the single story and multi-story framed portable frames in the steel structures. Next, coming to the third unit, eccentric and movement connections in the steel structures. First one, introduction. Next, beams and columns and roof beams and bracing beams. Next, coming to the eccentric shear force and bolted seat connections, bolted and bracket connections. Next, movement resistant connections in steel structures. Now coming to the fourth unit, analysis and design of industrial buildings, dead load, live load, wind load, design of wind speed, pressure and wind pressure, no roofs, wind effect on the roof trusses on the steel structures. Next, coming to the design of angular roof truss, tabular truss and design of built-up purlins, design of knee brace trusses, design of bracings in the steel structures. Next, last unit, design of steel trusses, girders in the bridges. First one, types of truss bridges, component parts of truss bridge, economic proportions of the trusses, self-weight of truss and girders, design of bridges and compression members, tension members in the steel members. Next, first thing, what is the need of this subject? What is the need of steel structures? Why you have to study the steel structures? Nowadays, we have to generally we can have to construct the RCC structures. Nowadays, we have to construct the steel structures. What is the use? It is a more high strength compared to RCC structures. High strength, high durability, ability to support to bearing the heavy loads compared to RCC structures. Mainly, it can be prefabrication of structures. Easily, it can replace the one place to another place, that type of structures. So, marketing involves the, nowadays, generally we can use the construct the toll gates like railway stations, we have to prefer to construct the steel structures only. Next, steel structures are load-bearing frameworks, interconnected structural components such as like columns, beams, and gusset plates, and bolted connections, welded connections, riveted connections, with the help of bolted connections and welding. These are all components are bearing the footing, gusset plate, with the help of gusset plate, with the help of the connection of footing to structure. Below the ground level, you have to provide the substructure. You have to construct the only RCC structure. Above the ground level superstructure, we have to connect the superstructure. Only you can use the steel structures. Types of connections. These are the three types of connections. Simple connections are known as shear connections. Okay, these are the three types of connections. First one is fine plate connection. Second one, cleat angle connection. Third one, end plate connection. Fine plate connection is generally you can providing the welded members flanged to the plate with the help of welding and bolted connection. Next, cleat angle connection. Cleat angle connection is known as the we have to providing certain angle to connect the column to beam. That type of connection is known as cleat angle connection. Now coming to the third one, end plate connection. The plate is welded or bolted to the end of the beam, which is then the bolted to the column. That type of connection is known as end plate connection. Next, simple connections are the three types of connections. First one, trusses and braced beams. Second one, non-movement resisting frames. Third one, industrial buildings and bridges. Now coming to the trusses and braced systems. They are often to use the structures like the trusses frames allow to thermal expansion of the contraction. Now coming to the non-movement resisting frames. When a structure frames does not require rigid continuity for load transfer, simple connections are efficient choice. Now coming to the industrial buildings and bridges. Their cost effectiveness, adaptability make them to common choice in various steel construction applications. Next, coming to the bolted connections in steel structures. Bolted connections are with the help of the one structure to another structure. We can with the help of the bolt to connect the one structure to another structure. The bolts are classified the strength, ordinary, unified, the lighter structural, high strength, heat treated bolts are heavier applications. These are the two types of bolts, bearing type of connection bolts, second one friction type of bolts. Now coming to the bearing type of bolts. Bearing type of bolts are load transferring direct pressure on the steel members to the holes on the connected plates on the steel members. Next coming to the friction type. High strength bolts create a high clamping force to generate the friction between the two connected plates. That type of connection is known as friction type. Next coming to the types of connections. These are the three types of connections. Welding connection, second one riveted connection, third one bolted connection. Types of connections vary gently depending upon the connection between the any two metals. We have to providing the welding or riveted connection, bolted connection. Next coming to the design of steel girders. Steel girder, it is nothing but a beam. It is a large type of beam. It is a eye-shaped girder. It is providing the large, heavy, large span structures and large structures and have to bearing the heavy loads. That type of girder is known as gantry girder. Majorly steel girders are involved in creating primarily horizontal support, often a I-beam plate girder carrying the loads, smaller beams are structures of elements. Design procedure details engineering codes IAS 800 to 2007. You can follow the Indian Standard IS code book. Next, use of steel girders. where we can use the steel girders. Steel girders are majorly we can providing the heavy loads acting on the structure. You can have to construct the providing the girders, like so for example bridges and valleys and railway bridges, waterfalls, where we can large loads acting on the location. We have to prefer the gantry girders. Design of industrial buildings in steel structures. Large multi-storied portable frames structures, you have to provide in the number of gantry girders are providing. You have to construct the durability and flexibility of the structures. Design of industrial buildings in steel structures, like godowns, cinema theaters, large type of malls, etc. So, for example of toll gates, they have to providing the columns. You have to providing the large type of girders. Why we can use the girders? It can be large span. It can be loading heavy load. It can be built. Advantages of steel structures. First one is steel offers much better compressive strength and tensile strength compared to the RCC structures. Second one, lighter constructions. Third one is unlike masonry reinforced concrete, steel can be easily recyclable. Fourth one is erection is faster with the contact of environmental moisture contact. So, prefabrication of structures and demountability. It can be easily remolding and replace the one place to another place. So, for example, approximately 10 years you can construct the one toll gate. After 10 years you can replace the toll gate is shifted to after 35 kilometers. It can be easily remove all the structural elements and reconstructed. Structural steel is used in load-bearing frames, buildings, truss members, bridges. It has high ductility and will withstand the extension deformation of the structures. Disadvantages of steel structures are it can be more cost compared to RCC structure. So, for example, RCC structures, which type of materials used? Cement, sand, steel, aggregates. So, in this RCC steel structures, completely you can use the steel. It can be more high compared to RCC structures. Skilled workmanships are required for the construction of steel structures. Skilled persons are working in the type of structures. Supervisions are needed for that type of steel structures. Regular maintenance is required for that type of steel structures. Regular maintenance is not required for the RCC structures. Susceptibility to buckling of steel structures. Next, coming to the less resistant to fire attacks in the steel structures. Types of steel structures. These are the 4 types of steel structure. First one, frame structure. Second one, truss structure. Third one is the arch structure. 3-hinged arches, 2-hinged arches structures. Next, coming to the suspension of structures. Suspension bridge. Suspension bridges are mostly we can observe in the valleys areas. What are the different types of sections of the steel structure? I section, T section, C section, H section, M section, O section, circular section, square section, rectangular section, plane section. Welded connections. How it can be works? Steel members are joined by the heating of fusing of steel rod with the help of one steel structure to another steel structure. It can be more strong with the help of welding. What are the advantages of welding? First one, create a solid, permanent, strong joint. Second one, provides greater rigidity and than the bolt joints. Third one is can be done in different ways depending on the joint, such as butt weld and fillet weld and slot weld. Next, coming to the bolted connections, how it can be works in the steel structures. Already you have to know bolted connections. The steel members we have the help of the one structure to another structure with the help of bolt. It can be easily removing the structures, easily fixing the structures with the help of bolts. The more advantages are quickly, relatively easily to assemble or disassemble the structures with the help of the bolts. Does not require high skilled laborers. Next, coming to the allows the simple inspection and maintenance. Now coming to the last one, provides the flexibility such as being able to remove or replace the components. In advanced steel structures, majorly it can advanced levels for the construction, multi-story different types of structures. It can be more durable and appearance for the type of construction in our world. Thank you.